Okay, so now we move to the last part of this lesson. So we are going to learn about coding. Okay, so what are we going to use coding in how do we use coding in statistical calculations? Okay, so what we do here by coding is actually they give you a way, basically it's a way to transform our data. Okay, so why do we use coding? It's a method of transforming our data. So normally most of the time in real life we use coding to actually make large data points. Now, some data values they get extremely large. So by using coding, you can make those extremely large data values. You can make it small so that it's easy for us to perform. So we can use the calculator to work with it. Okay. So when data values are large, it's going to present a much bigger challenge. So coding will help us to make that value small and we can work with it. Okay, so then they say here, so we are going to learn about several types of coding. Now in S1, there are several types of coding that we use. So look at these types. So if the data are coded using the formula y equals to x minus a over b, can you see what they're doing here? So your x value, the x is the original data value. You're subtracting it by some constant and also you're dividing. You need to realize the moment you subtract and when you divide, the value is actually going to become really small. That's the whole point, right? So they say here, if you use this sort of code, actually this is the sort of coding that we will be using everywhere in statistics. Okay, you don't need to worry about other big types, but this is mainly the type that you will be working. Okay, variations of this type is what you'll be working. So they say the mean of the coded data is given by y bar equals x bar minus a over b. Okay, and the standard deviation of the coded data is given by sigma y equals sigma x over b, where sigma x is the standard deviation of the original data. Okay, you know what? Let me show this to you in a proper example so that you can understand how coding works. So what I'll be doing is this. I'll first give you I'll give you the original data set, the X data set. And let's find the standard deviation and mean of the X data set, the original data set. Then what I'll do is I'll give you some coding. I'll give you a coding. And then let's apply the coding and and try to find the mean and standard deviation of the coded data set. So what's the whole point? What's the point of coding? Now after you code, after you make the data value small, you can find the mean and the standard deviation for the coded data, right? But is it the coded data that we really want? Now, at the end of the day, I want to find the mean and standard deviation of my original, the real data set. So the thing is, after using coding, we have to come back. We have to calculate the real mean, the real standard deviation. Okay, so that's what they are giving you these equations for. If by using these equations, you can come back to the actual mean. You can come back to the actual standard deviation. So let's see how to do that. Okay, so first I'll give you an example and let's see how these equations will work. Okay, so let's go for the example. Okay, so I have given you an example. So this is the original data set that I'm going to consider. Okay, so first let's find the mean and standard deviation of the original data set. And then I will give you a set of codings. We'll do those codings and see how to get the mean and standard deviation as in the original data set. Okay, first, number one, shall we find the mean? X bar mu. Let's get it. How do you find the mean? You add all the X values, right? So in this case, there's no frequency. So basically mean is sigma X over n. Add all the X values and divide by the number of terms. So divide by how many terms we have here? 110 plus, 120 plus, 120 plus, 130 plus, 140. You divide by n. Who is n? N is 5. How much is the addition? 620 divided by 5. How much is it? Divide by 524. So this is the mean. Can you see this data set for X data set? The mean of the data set is 124. Okay, and can we also find the standard deviation? So standard deviation is sigma x square over n. You have to remember the equations. Minus sigma x over n whole thing square. Okay, so this is the equation. So remember, this is the one, the equation that doesn't involve frequency, right? I have to use the equation that doesn't involve frequency. Guys, what is sigma x square? Sigma x square means you have to add all these x values by squaring it, right? 110 square plus 120 square plus 120 square plus 130 square plus 140 square. So you add everything and that gives you sigma x square. Can I know how much is sigma x square? 77,400. Is that correct? Divide by n. How much is n? N is 5. Minus sigma x. Sigma x is 620 over n is 5 whole thing square. And then root it. What do we get? 77,400 over 5 minus 620 over 5 whole thing square root of it. It is, get the decimal answer. 10.198. It goes on, right? 10.198. Okay, do you agree? This is the 3DP. Okay, you can make it 3SF and say 10.2. Okay. Right. Okay. So this is the X bar, the mean and the standard deviation of the original data set. Okay. Now let's go for the coding. Okay. So let's now go for the coding. Okay. Let's apply the coding. Y equals X minus 100 divided by 10. Let's apply the coding. So what does the coding do? So the coding will actually create a new data set. What does the coding do? It will create a completely new data set. So how do you get that new data set? So what are you supposed to do? Now the original data set is X. So now I'm going to create the new data set called Y. So how do you create the Y data set? From the X values, you're supposed to subtract 100 and divide by 10. So take every single X value and do it. So first X value is 110. So perform 110, you subtract 100 and divide by 10. What's the answer? 110 minus 100. That's 10. 10 divided by 10. The first data value is 1. Guys, can you see? 110 transforms into 1. Can you do the same thing for 120? 120 minus 100 is 20. 20 divided by 10 is 2. Next one, again 120 should become another 2. 130 becomes 3. 140 minus 100 is 40. 40 divided by 10 is 4. Guys, can you see what I just did over here? I took each and every single X value and applied it to this equation and I got the respective what value? Y value. So this is called the coded data. So the Y values we got here, this is what we refer to as the coded data. Guys, are you with me? So I'm going to now what? I'm going to find the mean and standard deviation of the coded data. Okay, let's find the mean and standard deviation of the coded data. Okay, so let's find Y bar. So what is Y bar? Sigma Y over N. Add everything. 1 plus 2 plus 2 plus 3 plus 4. Divide by N is 5. How much is it? 2.4. Guys, do you agree it's 2.4? Y bar. Y bar is 2.4. Now, the goal is Y bar our goal? Now, Y bar is the mean of the coded data set. So what are we, now the whole point of coding is now we get a data set that's smaller so we can easily find the mean. But is Y bar what we actually want? The final answer? No, what we really want at the end of the day is the actual original X bar. I want to go back to my X bar. How do we go back to the X bar? So that's what they have told you here. So if you have a equation of the format y equal x minus a over b, you can get the mean of the coded data. It's given by y bar equal x bar minus a over b. Are you seeing this? Can you all look at this? Can you all, do you get what's going on here? So over here, what's happening is you need to use the equation y equal x minus 100 over 10 means the coded equation is y bar equal x bar minus 100 over 10. Now guys, you can see y bar answer is what we have over here, which is what? 2.4. So replace y bar as 2.4 equals x bar minus 100 over 10. So 2.4 times 10 equals to x bar minus 100. 2.4 times 10 is 24 equal x bar minus 100. So 100 plus 24 is 124. Does this correspond to our original x bar? Yes, can you see? So this is why I took the original data values at the beginning, because I want to see once we use coding and we get the coded value and we are coming back to the original. I just wanted to check whether we get it correctly. Can you see that even though you use coding and when you come back to get the x bar, that we can come back to the original answer. Okay, that's what I wanted to show you here. Now, in the exam, when they give you this data set, you don't need to find the original x bar and the sigma. Okay, what are you supposed to do? You are supposed to get the y data set. You are supposed to get the new y data set and get the y bar, and using y bar only, you will calculate the x bar. Can you understand? So in this case, I just want to show you that it works correctly. That's why I have gone through these extra steps. So these are just to show you that it works correctly. Okay. So we'll go into the real exam questions in a moment. Okay. So we are not done yet. I have found the y bar, but I also have to find what? Standard deviation. Shall we also go for standard deviation? Okay, so let's go for standard deviation. How does that work? Sigma. Previously I found standard deviation of x. Shall we write that as sigma x? We found sigma x, right? Okay, now we are going with the coordinate data, which means we are going to find sigma y. Okay, let's find sigma y. So who is sigma y? Sigma y square over n minus sigma y over n whole thing square. Can you see? Sigma y square over n minus sigma y over n whole thing square. So this is sigma y. Agreed? Okay, shall we find the sigma y square value? How do you get sigma y square? You have to square all the y values and add. So 1 square plus 2 square plus 2 square plus 3 square plus 4 square. How much is it? 30? 34. Guys, do you agree? 1 square plus 2 square plus 2 square plus 3 square plus 4 square. That's 34. Over n is 5 minus sigma y. We found it earlier. Sigma y was how much? 12. Over n is 5. Whole thing square. And then we wrote it. Okay, and how much do we get? 1.019. It goes on, right? Okay, so this is sigma y. Okay, now how do we go? Now the thing is sigma y our final goal? No, this is y is the coded data. The whole thing, what we really require here is the standard deviation of the original data set. That's what we want. Okay, we need to get the standard deviation of our original x data set. So how do we do that? Look, they have told you when you have now you can see we have a coding of the form y equal x minus a over b, right? So pay attention to this. This is really important. Can you see how the standard deviation? Now you saw for the mean, it was not much different, right? Because y replaced with y bar, x replaced with x bar, minus a over b was there exactly as it is. But look at the standard deviation. Do you see something is different here? What's different here? Y has been replaced by sigma y. That's okay. X has been replaced by sigma x. That's also okay. The down denominator b is also there. The a is not there. The minus a. Can you see? So in standard deviation, what I want to emphasize here is the standard deviation is actually what you can see. It is not affected by the adding or the subtracting part. When you're doing an adding or subtracting, the standard deviation is not affected by it. So we will check whether that is true or not now. Okay, so we'll use the equation. Now, according to this equation, what do we have? According to this, y becomes sigma y, right? Sigma y equals the x becomes sigma x. Do we write the minus 100? No, I told you the adding subtracting part does not come. Over the division, are we writing it? Yes, the division part was there, right? Do I need to show this to you again? Compare these two. Can you see? Y has become sigma y. X has become sigma x. Can you see? And the division b is there. But the minus a is not there. Do you see? Okay, so we'll go with that. So here sigma x over 10. The minus 100 will not be there. Do you agree with me? Shall we check now? We know the actual sigma x answer, right? So I want to see whether the sigma x will come correctly because I actually know the real answer, isn't it? Can you see? We have already calculated sigma x to see. I want to see whether this coding actually does it work properly. Okay. So we'll see whether it's correct. Sigma y is how much? 1.0198. Sigma x over 10. So sigma x is equal to what? 1.0198 into 10, which means sigma x is 10.198. Guys, this is corresponding with the answer that we got previously. Sigma x, the sigma x answer we got was to 3dp 10.198. I think you can see that I get the exact same answer here. Can you see? So this is something that's really important. As you can see, now I think you understand clearly how coding works now, right? So can you see now when you are doing questions in the exam, are you going to find the x bar and sigma x for the original data? No, you don't need to. Okay, so they will give you the coded data. You will only find the mean and standard deviation of the coded data, and then using these techniques, you will find the the mean and standard deviation of the original data. That's what you are expected to do. So in the exam, you are expected to do this part. Do you get it? So I just wanted to cross check, double check whether these answers actually give the correct answer. That's what I was doing here. So this is not necessary for you to do. Is this clear? So this is really important and you need to write this down. Okay, you need to mark this down. So basically the standard deviation, as you can see here, standard deviation is not affected, is not affected by addition or even addition, no? By addition or subtraction. It's not affected by adding or subtract. Okay, standard deviation is not affected by addition or subtraction. So this is really important when you have this. Okay, so basically when you have the format y equal x minus a over b, okay, for to find the mean, the equation becomes y bar equal x bar minus a over b, right? Are you with me? But when you're finding the standard deviation, what happens to the equation? When you're finding the standard deviation, this equation becomes y becomes sigma y, x becomes sigma x. Are we writing minus a? No, divide by b. So this is extremely important. You need to remember in standard deviation, the minus mark, the minus a, that part does not count. That's extremely important. Okay. Okay, now let's go for the sums. Okay, so we'll move on to exercise 2G. So I'll be doing a few selected questions here. Let's go to question number 1. Okay, so question number 1, they say a set of data values x is shown below. Okay, so they've given you the values here. You can see it's in a random order, right? Okay, so anyway, we are saying use chord the data using the coding y equal x over 10. So shall we get the chorded data? So this is the set of x data values. So let's get the y set. So x divided by 10, 110 divided by 10 is 11, 90 divided by 10 is 9, 50 divided by 10 is 5, 80 divided by 10, 8, 30 divided by 10, 3, 70 divided by 10, 7, 60 divided by 10, 6. Okay, so chord the data, done. Part B, calculate the mean of the chord data value. How do you find the mean? Y bar is equal to sigma y over n. Guys, can you add everything? 11 plus 9 plus 5 plus 8 plus 3 plus 7 plus 6. How much? 49 over how many data points? 1, 2, 3, 4, 5, 6, 7 data points. So which means y bar is 7. So mean of the chorded data values is equal to 7. Okay, part C, use your answer to part B to calculate the mean of the original data. So how do you get the mean of the original data? So you get here y. Now you know you have to rewrite the equation, right? So in the mean, when you are rewriting for the mean, do you need to remove anyone? No, you remember in the previous case when we were working with the mean, we worked with the entire equation. When you had y equal x minus a over b, you did not remove anyone. Only the standard deviation had the issue with the plus minus. Okay. So for the mean, we can go with it. So which means I can rewrite the equation y equal x over 10 can be written as y bar equal x bar over 10. Just rewrite the equation. And then we know the y bar value is 7. 7 equal x bar over 10, which means x bar is 7 times 10, x bar is 70. So this is the mean of the original data. This is the mean of the original data. Okay. Question number 3. So next I choose question number 3. The coded mean price of a television in a shop was worked out. So what mean price have they worked out? The coded mean price, which means you have the mean for the coded data, not for the original data. Okay, using the coding y equal x minus 65 over 200. So in this case, who is the coded data? Y is equal to x minus 65 over 200. So which means y is the coded data, x is the original data. You need to understand it because sometimes they interchange these variables and give. Okay, so x is the original, you just subtract 65 divided by 200 and that gives the coded data for y. Okay, this is the coded mean price of a television in a shop was worked out using this coding. The mean price was 1.5. So guys, this mean price of 1.5 is which value have they given? The coded mean price is given, isn't it? So who is it? This is x bar or y bar? This is what they have given you here is y bar. The coded mean is y bar. Okay, because y is the coded data set. So coded mean is y bar, which is 1.5. So how do you find the true mean? True mean means to find x bar. So what do you do here? Rewrite the equation. What do you get? Y bar equal x bar minus 65 over 200. Y bar is 1.5 equals x bar minus 65 over 200. So 1.5 times 200 equals x bar minus 65. So how much is the answer? 1.5 into 200 and then you have to add 65, right? Can I have the final answer? 365. That is the true mean. The true mean price of the television is 365. Okay. Next, let's attempt question number 4. Okay, question number 4. They have given you here the coding y equal x minus 40 gives a standard deviation for y of 2.34. What have they given you? The coding is y equal x minus 40. And they say it gives a standard deviation for y of 2.34. Who is 2.34? This means 2.34 is sigma y. Sigma y is 2.34. Are you with me? Okay, they're asking you write down the standard deviation of x. So how do we write the standard deviation of x? So take the equation first. Rewrite the equation according to the rule of standard deviation. So how does that rule work? So y equals x minus 40. Do you recall how we write the equation? Y becomes sigma y. X becomes sigma x. What about the minus 40? I told you as we did earlier, minus 40 or plus these my addition subtraction will not make any impact on the standard deviation. So minus 40 will not come. In this case, do we have any division to perform? No. That's it, which means what? Sigma y is directly equal to sigma x, which means what's the standard deviation of x? Standard deviation of x is directly 2.34, nothing to change. It's the exact same answer. Okay, so then you can see here I have actually constructed the table that is required here. So they have said the lifetime x in hours of 70 light bulbs is shown in the table below. So this is the table. Okay, so lifetime in hours, and they have given the ranges for the lifetime and the frequency of the light bulbs that fall within each range. The data are coded using y equal x minus 1 over 20. Okay, so however, to code the data, first you need the x values, right? So you can see in this case, your x values are given in a range. So when you get x values in a range to code, first what do? You need the proper x value. So the proper x value, what we consider here is the mid value. Okay. Right, so let's get the mid value and they're asking us to estimate the mean of the coded value y. Then hence find an estimate of the mean lifetime, estimate the standard deviation of the lifetime. Okay, so before we go into any of that, we have to first get the mean, the coded data. And then they want us to find the mean of the coded data. Let's do that. So lifetime is between 20 to 22, 22 to 24, 24 to 26, 26 to 28, and 28 to 30. Frequencies are given as 3, 12, 40, 10, 5. Okay. And then how do we get the mid value? We add the two points at the we add these 2 points and divide by 2. So 20 plus 22 divided by 2 is 1. Sorry, 21. 22 plus 24 divided by 2, 23. This is 25. You can see the midpoint is directly 25, right? We can see it. 27, 29. That's easy. Okay, then we'll go for the coding. Now we are going to perform the coding. They have told us how to perform the coding. You have to subtract 1 and divide by 20. Okay, so shall we do that? So how does it come? Okay, so what do we do here? So the x value is 21. So 21 minus 1. 21 minus 1 over 20. How much is it? 21 minus 1 is 20. Divided by 20. That is 1. Next one. 23 minus 1 over 20. 23 minus 1 is 22. 22 divided by 20 is 1.1. So guys, you need to remember the mid value is what we use for x here. Okay. Okay, this is frequency, mid value, because this is the mid value of the lifetime. So we are trying to code the lifetime here. Okay. So the mid value is what we use for x here. That's important. Okay, then next one, 25 minus 1 over 20 is 1.2. Next one, 27 minus 1 over 20 is 29 minus 1 over 20, 1.4. Okay. So then why am I going for Fy? The reason is because they're asking us to get the mean of the coded values of y bar. So when you have y bar, in this case, can we go for sigma y over n? Sigma y over n is correct if you have a simple data set of points. But over here, you have a data table with frequency. If there's frequency involved to get y bar, okay, if there's frequency involved to get y bar, you have to use sigma Fy over sigma f. Like for x bar, we use sigma fx over sigma f. So y bar is sigma Fy over sigma f because it involves frequency now. So let's get Fy. So Fy means you multiply frequency with the y value. Really important. Please make sure you multiply the correct columns. Okay. So frequency 3 multiplied by y is 1. 3 times 1 is 3. 12 times 1.1. 12 times 1.1. 13.2. 40 times 1.2. 48. 10 times 1.3. 13. 5 times 1.4. 7. Okay, so time to add everything. You have to add the frequency. And I need the total Fy. How much is it? 3 plus 13.2 plus 48 plus 13 plus 7. So add everything. What do you get when you add all of this? 84.2. Okay, so this is all I need here. And sigma f is the total frequency. I think they have told us here. This is 70 light bulbs, right? This should add up to 70. All right, so then let's get sigma Fy over sigma f. Sigma Fy is 84.2 over sigma f is 70. Sigma Fy over sigma f. Total frequency is 70. Okay, how much is the answer? 84.2 divided by 70 is So you get a long decimal, right? 1.202857. It goes on. Okay, so we'll correct it to maybe 3SF 1.20, right? 1.20 hours. Sorry, this is the coded data. We can't go for hours because we are working now not with the original. The X data is the lifetime in hours. So why is the coded data? So I'm getting what mean here? I'm getting the coded mean. Actually, the question was also asked us to find the coded mean. Okay. Okay, so then that's done. So we found the mean of the coded values y bar. Part B, they say hence find an estimate for the mean lifetime of the light bulbs x bar. They're asking you to get what? X bar. So how do we get x bar? So you know the rule. Now if you have y equal x minus 1 over 20, you know you can convert this to the x bar y bar equation. How does it work? Y bar equals x bar minus 1 over 20. Are we removing the minus 1? No, because we are working with the mean. When you are working for the mean, the minus plus does not remove. Okay. So y bar, we got the answer as what? 1.202. You can use a few extra decimals if you want. 857. X bar minus 1 over 20. Okay. So which means x bar will be 1.202857 into 20 and then add 1. Got it? And give it to maybe 3SF 1.2. Yeah, so it's 25.057, which means 25.1. And this time you can go for hours. You can write hours because you're finding the mean for x value and x represents the lifetime in hours. So the x has a proper unit. So you can say, okay, so our mean lifetime of a light bulb is 25.1 hours. Agreed? Okay, and then let's go for part C. Okay, so what do they say in part C? Okay, they say here in part C, estimate the standard deviation of the lifetimes of the light bulbs. So how do we go for the standard deviation? So the best way to do here is to actually continue with Fy square. Okay, because standard deviation means you would need to get Fx square. Now going for that is going to be, I mean, since we have already got Fy, okay, so we can go for Fy square and use the standard deviation equation and get sigma y. And then we can get it back to sigma n, isn't it? So let's go like that. Okay, can I have Fy square? So multiply frequency with the y value, the square of the y value. So 3 multiplied by 1 square. 3 multiplied by 1 square, which is 3. And then 12 multiplied by 1.1 square. 14.52. And then 40 multiplied by 1.2 square. 57.6. The next one, 27 multiplied, sorry, frequency, 10 multiplied by 1.3 square. Yeah. 16.9. 5 multiplied by 1.4 square. 9.8. Okay, so now add everything. 3 plus 14.52 plus 57.6 plus 16.9 plus 9.8. What do you get? 101.82. This is sigma Fy square. 101.82. Okay. All right. And then, so it's time to find the standard deviation. Part C, standard deviation. Oh, actually, we are finding sigma y, right? Sigma y equals sigma Fy square over sigma f minus sigma Fy over sigma f holding square. Sigma Fy square, that's 101.82 over sigma f is 70 minus sigma Fy is 84.2 over sigma f is 70, whole thing square. Agreed? Okay, so input the values and now let's get the answer for sigma y. What is sigma y? So we get here 0.0877845. It goes on. It goes on. Okay, so this is not the final answer because they're asking us to get the standard deviation of the lifetimes of the light bulbs. So, you know, now we have got the chorded standard deviation. I need to get sigma x. I have found sigma y. How do we get sigma x? So do you recall how to get the answer here? Y equal x minus 1 over 20. So if you have y equal x minus 1 over 20, how do you rewrite this with sigma? You get here sigma y equals sigma x minus 1 doesn't come. Divide by 20. Okay, so sigma y is given to us as, we got it as 0.0877845. Sigma x over 20 multiply by 20. 1.75569, it goes on. So let's make it to 3SF. Sigma x is 1.76 hours. Correct to 3 significant figures. Okay, so this is the answer, correct to 3 significant figures. Okay, this is, I hope this is clear with all of you.